function operations. So let f of x be the function 5x plus 2. Its domain is all real numbers because it's a linear function. G of x be the function negative 4x plus 1. Its domain is also all real numbers. And h of x equal 5x squared plus 2x. And because this is a quadratic function, its domain is all real numbers. If we want to look at the sum of two functions, f plus g of x, we're going to look at f of x plus g of x. So 5x plus 2 plus negative 4x plus 1. If I combine my like terms, 5x, negative 4x, we have x, 2, and 1 is plus 3. So f of g of x equals x plus 3. Its domain is going to contain the elements that are in both the domains of f of x and g of x. And since both f of x and g of x have the domain all real numbers, the domain of their sum is also all real numbers. Let's look at the difference, f minus g of x. This is the same as f of x minus g of x, or 5x plus 2 minus negative 4x plus 1. I'm going to distribute the negative, so we get plus 4x and minus 1. Combining like terms, 5x and 4x is 9x. 2 and negative 1 is 1, positive 1. So f minus g of x equals 9x plus 1. The domain of this difference will also contain those values that are in both f of x and g of x. And again, because both of those functions have a domain of all real numbers, the domain of the difference is also all real numbers. Let's look at the product, f times g of x. This is the same as f of x times g of x. So f of x is 5x plus 2. G of x is negative 4x plus 1. We'll FOIL or distribute. So 5x times negative 4x is negative 20x squared. 5x times 1 is positive 5x plus 2 times negative 4x, which is negative 8x. Those combine to be negative 3x. And then 2 times 1 is positive 2. So the product, f times g of x, is equal to negative 20x squared minus 3x plus 2. Now again, its domain is going to contain those values which are in both f of x and g of x. And because f of x and g of x both had the domain all real numbers, the domain of the product is also all real numbers. Okay, one more operation, the quotient. H divided by f of x. This is the same as h of x over f of x. Okay, so h of x is 5x squared plus 2x over f of x, which is 5x plus 2. Let's factor the numerator by factoring out an x. That's the greatest common factor. That leaves 5x plus 2 in parentheses. And again, the denominator stays as 5x plus 2. We can cancel out the 5x plus 2's, and we get that this quotient is equal to x. Now we need to be careful because this denominator, in order for this quotient to exist, the denominator cannot equal 0. So let's set 5x plus 2 equal to 0 and solve for x. So subtracting 2, 5x equals negative 2, dividing both sides by 5, x equals negative 2/5. So we could say that this is a restriction, that x cannot equal negative 2/5. That means the domain here is going to include all the values in the domain of h of x and f of x, but not including negative 2/5. So I can write this in interval notation as negative infinity to negative 2/5 union negative 2/5 to positive infinity. This means all real numbers, but not negative 2/5. Just as a summary about the domains, the domain of the sum, difference, product, and quotient functions includes those values in the domain of both. But the quotient will also contain a restriction.